Hello everyone. In this video, we are going to discuss a set of SAT math problems. Here we have the first problem. A quadratic function models a height in feet of an object above the ground in terms of the time in seconds after the object is launched off an elevator surface. The model indicates the object as an initial height of 10 feet above the ground and reaches its maximum height of 1034 feet above the ground 8 seconds after being launched. Based on the model, what is the height in feet of the object above the ground 10 seconds after being launched? Okay, now let me draw an XY plane. Over here, we have the y-axis and here we have the x-axis. And I take the time on x-axis in seconds and I take the height of the object on y-axis in feet. Okay, let me take the value 10 on the y-axis over here. And the question says that the initial height of the object is 10 feet above the ground. So this is the initial height. So this is a position from where the object is launched. The object keeps going up and it has reached the maximum height of 1034 feet. So then we have the value 1034 feet on the y-axis over here. When the time is 8 seconds, then we have to take 8 on the x-axis over here. After reaching the maximum height over here, the object starts coming down. Okay, now, so the path of the object is a parabola with the vertex 8, 1034. Okay, here we know the vertex of the parabola, that is 8, 1034. So we can write the quadratic function in vertex form, which represents the path of the object. So the vertex form of a quadratic function is y equals to a times x negative h whole square positive k. Here y equals to a times x h is the x coordinate of the vertex, that is 8 seconds, x negative 8 the whole square, positive k is the y coordinate of the vertex, that is a height 1034. Okay, here the quadratic function is not complete because it contains an unknown constant a. To find the value of this constant, we need a point on the parabola. Let's consider this point. Actually, this is a y-intercept of the parabola because at this point the parabola intersects y-axis. The y-intercept always the x-coordinate is 0 and the y-coordinate is 10. Now, we can plug in this point into this quadratic function to get the value of a. Okay, let's plug in the x-coordinate 0 for x and the y-coordinate 10 for y. Then we have 10 equals to a times 0 negative 8 the whole square positive 1034. Okay, let me subtract 1034 from both sides of the equation. Then this positive and negative value will cancel out. When I simplify this one, I am getting negative 1024 equals to a times 0 negative 8 is just negative 8. When I square negative 8, it will become positive 64. Now we can divide both sides of the equation by 64. Then the 64 will cancel out. Okay, let me divide 1024 by 64. Then we get 16. That is the simplification of this one is negative 16. On the right side, we have a. Okay, here I got the value of a. Now, what we can do is we can plug in the value of a over here in this quadratic function. Then we have y equals to negative 16 times x negative 8 the whole square positive 1034. And our aim is to find the height of the object around 10 seconds after being launched. That is, we have to find the value of y, that is height of the object when time is 10 seconds. That is the value of x is 10. So let's plug in 10 for x over here. Then we get y equals to negative 16 times 10 negative 8 the whole square positive 1034. Okay. Now let me do some simplification over here. So 10 negative 8 is 2. The value of 2 square is 4. 4 times negative 16 is negative 64 positive 1034. Okay, here when I combine this negative value and positive value, I am getting 970. That is when time 10 seconds, the height reached by the object is 970 feet. We find 970 in answer choice C. The correct answer choice for this question is C. Okay, let's look at the next problem. H of x equals to x cube positive ax square positive bx positive c. The function h is defined above where a, b and c are integer constants. If the zeros of the function are negative 5, 6 and 7, what is the value of c? So we have to find the value of the constant c in the given function. And the question says that these c numbers are zeros of the given function. That is, the graph of the given function as x-intercepts are these three values. So the first x-intercept is negative 5, 0. And the second x-intercept is 6, 0, and the third x-intercept is 7, 0. And usually when we have the function like h of x over here, this h of x gives a value of y. So we can replace this h of x by y. Then the given function will become y equals to x to the third power positive ax square positive bx positive c. Further, we can solve this problem using Desmos. Okay, in Desmos, first we have to take these 3 points as input. So click on the positive sign over here, go to the table. So the first point is negative 5 comma 0, and the second point is 6 comma 0, and the third point is 7 comma 0. Okay, now we have to take this equation as input. And here my aim is not to grab this equation. My aim is to find the value of the unknown constant c. In that case, when I take this equation as input in Desmos, instead of x, I have to take x1. Instead of y, I have to take y1. And for equal sign, I have to use tilde sign. Because here we have x1 for exponent and y1 for y coordinate. Okay, now let me take this equation as input in Desmos. That is y1, then we have to take tilde sign. Then x1 cube, x1, it has to be raised to the power of 3. Then positive a times x1 squared positive b times x1 negative c. Here I got the values of a, b and c, and the information says all the 3 constants a, b and c are integer constants. Here the values we got over here for a, b and c are all of them are integers. Our aim is to find the value of c. So here the value of c is negative 210. Okay, let's look at the next question. The quadratic function g models the depth in meters below the surface of the water of a seal t minutes after the seal entered the water during a dive. The function estimates that the seal reached its maximum depth of 302.4 meters 6 minutes after it entered the water, and then reached the surface of the water 12 minutes after it entered the water. Based on the function, what was the estimated depth to the nearest meter of the seal 10 minutes after it entered the water? Okay, now let me take a vertical axis over here and also an horizontal axis over here. And I consider the time t on the horizontal axis in minutes, and the depth on the vertical axis in meters. Okay, according to the given information, the seal entered the water and reached the maximum depth of 302.4 meters in the time 6 minutes. Okay, now let's assume the seal entered into the water at the point origin where the time is 0 and the depth is 0. Okay, now it keeps going down. At one stage, it reaches the maximum depth, 302.4 meters. Then we'll have this value on the vertical axis. Since we have the maximum depth is below the horizontal axis, so this depth should be taken in with negative sign. Okay, then we have the value negative 302.4 over here. And the seal reached this maximum depth when the time is 6 minutes. Then we have to take this 6 on the horizontal axis over here because we have the time on horizontal axis. Okay, after reaching the maximum depth, it starts coming up and it has reached the surface of the water 12 minutes after it entered the water. Then we have 12 over here. Okay, now let's consider the path of the seal. Clearly, it's a parabola which opens up, and this maximum depth represents the vertex of the parabola. Okay, here we have to take the coordinate on the horizontal axis, that is 6, and now let's take the coordinate on the vertical axis, that is negative 302.4. So this is the vertex of the parabola, and here the seal reached the surface 12 minutes after it entered into the water. So this is the x-intercept of the parabola, that is we can write 12 comma 0. Since we have the vertex of the parabola, we can write the quadratic function in vertex form, that is y equals to a times x negative h whole square positive k. But instead of y, we have d on the vertical axis. We can write d over here, a times for x we have t on the horizontal axis. Okay, then we have t, and h is the x coordinate, I mean t coordinate of the vertex, so that is 6 and whole square, and k is a y coordinate, I mean a d coordinate, that is a negative 302.4. Let me write over here. Still, the quadratic function over here is not complete because there is an unknown constant a. To get the value of this constant a, we have to use one of the points on the parabola. So we can consider either the origin 0, 0 or the other x-intercept 12, 0. Whenever we can use the origin, it will be easier for us to do calculation. Okay, so let's plug in this t coordinate 0 for t over here and d coordinate 0 for d over here. We get 0 equals to a times 0 negative 6 whole square negative 302.4. Okay, let me add 302.4 to both sides of the equation. Then this negative value, positive value will cancel out. We get 302.4 on the left side. And 0, negative 6 is negative 6. When we evaluate the value of negative 6 whole square, it will be 36. We get 36a. Let me divide both sides of the equation by 36 to solve for a. Then this 36 will cancel out. Okay, now let me divide 302.4 by 36. I am getting 8.4 as the value of a. Let me write over here 8.4 equals to a. Okay, now what we can do is we can plug in this value 8.4 for a over here. Then the quadratic function become d equals to 8.4 times t negative 6 whole square negative 302.4. Now the quadratic function is complete. And our aim is to get the depth of, estimated depth to the nearest meter 10 minutes after it entered the water. So that is we have to plug in this 10 for t over here and find the value of d. Okay, let me do it. D equals to 8.4 times 10 negative 6 whole square negative 302.4. Then d equals to 8.4 times 10 negative 6 is 4 square is 16. Negative 302.4. Okay, d equals to, when I multiply this one and this one, I am getting 50.4 negative 302.4. When I simplify this one, I am getting negative 252. Okay, here we get a negative value for d because this is a depth and it's below the horizontal axis. So the estimated depth to the nearest meter of the sea 10 minutes after it entered the water is 252. Okay, let's look at the next problem. For the exponential function f, the value of f of 1 is k, where k is a constant. Which of the following equivalent forms of the function f shows the value of k as the coefficient or the base? So in the given answer choices, I have to find the function f of x where the value of k is shown as the coefficient or the base. How do you have to get the value of k? To get the value of k, let's consider this information. That is f of 1 is k. So to get the value of k, we have to plug in 1 for x into the function f of x. Okay, now let me get the value of k for the function f of x in answer choice A. That is, we have to plug in 1 for this x. Then we have 50 times 2 to the power of, so let's plug in 1 for x over here. Then we get 1 positive 1, which is equal to 50 times 2 to the second power, which is 4, and 50 times 4 is 200. Here I got the value of k for the function f of x in answer choice A. But the function f of x over here does not show this value 200 as the coefficient or base over here. So we can reject answer choice A. Now let me consider answer choice B. Let's find the value of k over here. That is, we have to plug in 1 for x into the function. Then we have 80 times 2 to the first power. 2 to the first power is just 2. 2 times 80 is 160. Here we have the value of k, that is 160. But the f of x in answer choice B does not show this value as a coefficient or base over here. So we can reject answer choice B. Okay, now let's verify answer choice C. That is k equals to f of 1. Then we have 128 times 2 to the power of, let's plug in 1 for x over here. Then we get 1 negative 1. Then we get 128 times 2 to the 0th power. Any non-zero number is raised to the power of 0 is equal to 1. So that is the value of this one is 1. 1 times 128 is 128. Here I got the value of k for the function f of x in answer choice C. And the function f of x shows the value of k, that is 128 as a coefficient over here. So in the given answer choices, the function f of x in answer choice C shows the value of k as a coefficient. The correct answer choice for this question is C. Anyways, we can verify the answer choice D. K equals to f of 1 equals to 205 times 2 to the power of 1 negative 2, which is equal to 205 times 2 to the power of 1 negative 1. Then we get 205 divided by 2 to the first power. Since we have negative exponent over here, I just move this one to denominator. Then the exponent will change its sign. That is, it will become positive 1. So 2 to the first power is still 2. when I divide 205 by 2, I am getting 102.5. Okay, here I got the value of k. Now let's verify the function f of x over here. F of x does not show this value as a coefficient or base over here. We can reject answer choice D as well. So the correct answer choice for this question is C. Okay, let's go to the next question. The rational function f is defined by an equation in the form f of x equals to a over x positive b, where a and b are constants. The partial graph of y equals to f of x is shown. If g of x equals to f of x positive 4, which equation could define g? Okay, let's consider the graph that we have for the function f of x. And here we can consider 2 points on the graph of the given function f of x. The first point we can take it over here. The x coordinate is -7 and the y coordinate is -2. Okay, now let's consider another point on the graph over here. X coordinate is -6 and the y coordinate is -3. And in this function f of x, this f of x represents y. So we can replace this f of x by y. Then we have y equals to a over x positive b. Okay, now to get the function g of x, first we have to get the function f of x. If I want to get the function f of x, I must know the values for the constants a and b. Now we can use the Desmos to get the values of the unknown constants a and b in the function f of x. Okay, for that we have to take these 2 points as input in Desmos. Okay, here click on this positive sign, go to the table. The first point is -7, -2. And the second point is -6, -3. Okay, now what we have to do is we have to take this equation as input. And here my aim is not to graph this equation. My aim is to get the values of the unknown constants a and b. In that case, when I take this equation as input in Desmos, for y I have to use y1, for x I have to use x1, and for equal sign I have to use a tilde sign. Okay, now let me do it over here. That is y1, then we have to take tilde sign, a over x1 positive b. Here I got the values for a and b. A equals to 6 and b equals to 4. Let's plug in the values of a and b over here into the function f of x. Then we get f of x equals to 6 over x positive 4. And our aim is to get the function g of x. And we have the information g of x equals to f of x positive 4. Okay, g of x equals to, now to get the stuff for x, f of x positive 4, we have to plug in this x positive 4 for x over here. That is, we have to plug in this x positive 4 for x. Then we get 6 over x positive 4. And we can write this positive 4 over here. Then we get 6 over x positive 8. Okay, here I got the function g of x. That is, g of x equals to 6 over x positive 8. We find this stuff in answer choice C. So the correct answer choice for this question is C. Okay, let's go to the next problem. Let the function p defined as p of x equals to x negative c the whole square positive 160 divided by 2c, where c is a constant. If p of c equals to 10, what is the value of p of 12? Okay, to get the value of p of 12, we have to plug in this 12 for x over here into this function. But before that, we must be knowing the value of the constant c that we have in the given function. For that, we can use this information. That is, p of c equals to 10. And we know that this is the stuff we have for p of x. Now, to get the stuff for p of c, we have to plug in this c for x over here. Then we get c negative c the whole square positive 160 divided by 2c equals to 10. C negative c is 0. The 0 square is 0. 0 positive 160 is 160. And in denominator, we have 2c equals to 10. 2 goes into 2 1 times and 2 goes into 160 80 times. We have 80 over c equals to 10. Let's take a reciprocal on both sides. Then I'm getting c over 80 equals to, on the right side, the reciprocal of 10 is 1 over 10. Let's multiply both sides of the equation by 80 to solve for c. This 80 will cancel out. 10 goes into 10 1 times and 10 goes into 80 8 times. I'm getting c equals to 1 times 8 is 8. Okay, here I got the value of c. Let's plug in this value 8 for c into the function p of x over here. Then p of x equals to x negative 8 the whole square positive 160 divided by, when I plug in 8 for c over here, we get 2 times 8, that is 16. Now the function p of x is complete. To get the value of p of 12, we have to plug in 12 for x over here and also here. Okay, then we have P of 12 equals to 12 negative 8 the whole square positive 160 divided by 16. Okay, let me continue over here. P of 12 equals to 12 negative 8 is 4 and we have 4 square. The value of 4 square is 16 positive 160 divided by 16. P of 12 equals to when I add these two numbers, I'm getting 176 divided by 16. P of 12 equals to, when I divide 176 by 16, I am getting 11. Here I got the value of P of 12, that is 11. We find 11 in answer choice D. The correct answer choice for this question is D. Okay, let's go to the next problem. The function g is defined by g of x equals to x times x negative 2 times x positive 6 a whole square. The value of g of 7 negative w is 0, where w is a constant. What is the sum of all possible values of w? Okay, now let me consider this particular stuff. That is g of 7 negative w is 0. You can write this one as an equation. That is g of 7 negative w equals to 0. And this is the stuff we have for g of x. Now to get the stuff for g of 7 negative w, we have to plug in this 7 negative w for each x we have over here. Then we get 7 negative w times 7 negative w negative 2 times 7 negative w positive 6 a whole square equals to 0. I plugged in this one for each x in this expression. Okay, 7 negative w. Let's do some simplification over here. When I combine this positive 7 and negative 2, I am getting 5. That is, we get 5 negative w. And here, when I combine this positive 7 and positive 6, I am getting positive 13. That is, positive 13 negative w, the whole square equals to 0. Here, the product of these three quantities is equal to 0. Whenever the product of two or more quantities is equal to 0, then one of the quantities has to be 0. So the first one may be 0, or the second one may be 0, or the third one may be 0, so that the product can be equal to 0. Okay, if the first one is 0, we get the equation 7 negative w equals to 0. If the second one is equal to 0, we get the equation 5 negative w equals to 0. If the third one is 0, then we get 13 negative w the whole square equals to 0. Okay, if I solve for w in this equation, I am getting w equals to 7, and in this equation, I am getting w equals to 5. And in this equation, first we have to get up the exponent 2. For that, we have to take square root on both sides of the equation. Here, the square root and square root cancel out. I am getting 13 negative w on the left side. On the right side, square root of 0 is 0. If I solve for w in this equation, I am getting w equals to 13. I got three possible values for w, 7, 5 and 13. And our aim is to get the sum of all possible values of w. So that we have to add these three values of w, that is 7, positive 5, positive 13. When I add these three values, I am getting 25. Therefore, the sum of all possible values of w is 25.